A circuit is given like this, and all resistances are given. All the resistances are given. Okay, and see here, you want to find R equivalent. If you want to find R equivalent, that means the resistance between the terminals A and B. That resistance between the terminals A and B. Okay, if you have two resistances in series, what will you do? If you have two resistances in series, you are going to simply add the resistances R1 plus R2. The total equivalent resistance between A and B is R1 plus R2. Okay, if you have two resistance, Ma, please mute yourself. Okay, so if you have two resistances in parallel, okay, that is R1 and R2 are in parallel. What is the total equivalent resistance between these two terminals A and B? Suppose this is A and this is B. So the equivalent resistance between A and B is R1 R2 divided by R1 plus R2. Okay, so this we are going to use now. Okay, these two you are going to use now uh, and simplify this circuit or reduce this circuit. So if you see here, the 1 ohm resistance and 5 ohm resistance are in series, right? So first you apply that series and you minimize that, simplify this series circuit so that two resistances are in series. So what I can do, I can write it as a simple one value that is equivalent to 6 ohms because it is 5 ohms plus 1 ohm, that is 6 ohms. Okay, so this is 6 ohms and this is your 4 ohms. Okay, instead of writing 1 ohm and 5 ohms separately, I am adding these two because they are in series. This is your 2 ohms. Okay, this is your 2 ohms. And here you can see there are two resistances. Okay, two resistances, 6 ohm and 3 ohms. How they are? They are in parallel. They are in parallel. Okay, so they are in parallel. So here 8 ohms resistance is there. Okay, so this is 8 ohms resistance and this is your terminal A and terminal B. Now 6 and 3 are in parallel. So the parallel combination, when you have two resistances in parallel, what is the formula you have to use? R1 R2 by R1 plus R2. So instead of R1 6 and R2 is 3. So 6 into 3 divided by 6 plus 3, that is 9. Okay, so 6 into 3 by 9, 6 into 3 by 9, that is equal to 2 ohms. So this entire two elements can be replaced by how much? 2 ohms. So again now my circuit will be reduced. Okay, so there is a change in the circuit after this 2 ohms is there. Okay, so here 4 ohms is there and here 6 ohms is there. And instead of writing these two, what I'm going to do, I'm going to write only one element called 2 ohms. Why I'm writing 2 ohms? Because I got 2 ohms as the answer. So this is your 6 ohms and this is your 8 ohms. Now, how these 2 ohms and 2 ohms are there? 2 ohms and 2 ohms are in series. So this is your terminal A, this is your terminal B. So this is 4 ohms and this is 4 ohms. Okay, and this is 6 ohms. This is 6 ohms and this is 8 ohms. This is 8 ohms. This is your 4 ohms. Now, how these 4 and 6 are there? Are in parallel. So 4 into 6 divided by 4 plus 6, that is 10. That is equal to 2.4 ohms. So the parallel combination is 2.4. So this again, this is reduced to 4 ohms and 2.4, 4 ohms, 2.4 ohms and 8 ohms. 8 ohms. So this is your A and B. Now 4, 2.48 are in series. So R equivalent is equal to 4 plus 2.4 plus 8. So how much it will be? 14.4. So this is your answer.